Hi everybody, just want to share a lesson I had on Friday which was exciting. I've not done something like this before, so just thought I'd have a try at it. If it finds the light of day, I guess it's aimed at the middle school teachers, so if it ends up on a whole school blog or something, um, yeah, it's probably everyone's welcome to look at it, so it's probably just relevant for the middle school teachers. It was a a six, seven lesson on maths. In particular, just at the beginning of the percentages unit that we're about to start, and we also looked at graphical representation of data, so it sort of crossed over a bit there. It's on pie charts, so things you would need for this lesson: a bucket of protractors, or the bucket of protractors, which I kind of kept hidden until they were asked for. Once a few people asked, the sort of cat was out of the bag, so that was fine. But I kept them hidden to start with, and also some compasses or something for them to trace circles that weren't the protractors, so they weren't sort of thinking of that. And apart from that, just access to the devices and just the usual stationery. And I used the maths scrapbook. The maths lesson was after recess, so as I went to recess, I had the following table up for them to complete for which high school they were going to be going to next year, or for the year sixes, which high school they were most likely to go to. And they only had to put 1 mark each, and I asked them to tally it. So as they left for recess, I sort of asked them what do they think this was going to lead into for the lesson after recess, and just left them pondering, which I'm sure kept them busy all recess, just wondering about what maths was going to be after recess. On return to the class, I'd tallied, they'd actually tallied correctly, so I explained that was good, how they'd used the tally system. I'd put in the numerals for each result in that row, and we just quickly discussed the data, the results, talked about the spread of the data, and it was all fairly even. I'd eliminated a couple of schools that weren't originally, that had 0 responses. I'd just take them out to keep it simple. And we talked about graphical representation, particularly if this had been a much larger group, maybe if it was the whole school responding to something, or the whole state, or suburb, whatever. That graphical representation would make it a lot easier to get that quick idea about how the data is distributed. Whether there's a really clear winner or whatever. So I then drew a column graph on top of the table, and we just discussed and talked about how much easier that was to quickly get an idea about that. And if you needed to, then you could burrow into the actual figures. That led into talking about pie charts, which they were fairly familiar with. And I didn't mention, one other thing you need to prepare before the lesson is to have some images of pie charts. I took some photos of the metacognition results that are up, particularly in Andrew's class, but Hazy had some here too, so I took some photos of those. Of course, that's great because it relates to them, but I also had just some straight off of Google Images. So we discussed what a pie chart was and what the features of the pie chart were, some sort of question or title that it represented, a key or whatever. And they all noticed that some of the pie charts, sometimes quite often, had a percentage labelled in there. And so we worked out that each piece of the pie sort of represented a percentage of the total pie. And that that they nearly always used different colours for the pieces of pie as the key. I then just basically told them to get into pairs and go for it, that I wanted them to make a pie chart of the data which we had regarding the high schools. I was really impressed with them. They, of course, first thing they asked is could they use devices. 3 or 4 groups used the apps on the devices to actually generate the pie charts, and quite quickly, within 7 or 8 minutes, had pie charts. So they were using either numbers or pages, and so yeah, they were getting that up. Some were asking for things to trace, finding some circles, and we're just starting to sort of estimate what it would be, what each result would be, just sort of an estimated piece of pie. So that was all good. After about 7 minutes, I pulled them up and told them a new rule, that their final Their final pie chart had to be drawn by hand, um, and so while they can use their devices for calculations and tables and stuff, the final thing needed to be done by hand. Um, so uh, I also sort of asked them, because some of them had already done this, so we worked out that maybe a next step would have been to tally up the total number of people who had responded, and then I'd let them go again. After 5 or 6 minutes, people were sort of starting to get some good ideas. A few people were not going where I wanted them to go, but I was pretty impressed with the things they were coming up with. So trying to break the circumference of the circle into the 30 pieces, and then counting and drawing a line back to the radius. So that if they had done that circumference accurately, that was actually quite a good way to do it, but of course it was quite difficult to do. So I pulled them up about another 5 or 6 minutes, and we talked about that each result was like a ratio of the total number of people who'd responded, and we could represent that as a fraction. So we drew in another row and made up the fractions and worked out what did those fractions all need to add up to. Of course, 1, which in this case was 30 on 30. So we were getting a bit of recapping or going back, revision, over the ratios were the same as fractions, of course the unity, and that they should all, if we're going to get a fraction for a whole body of information, all those ratios should add up to 1. And then I think I let them go for a while, but probably didn't. I probably could have gone to the next step, which was calculating a decimal from the fraction, or I think possibly just let them go. I certainly did just let them go now for a bit longer, and decided the lesson was actually going. I was really impressed with how it was going, so I decided I would make the lesson longer than I had actually planned. So I let them go again, all calculating the fractions and making sure that they got to the 30 on 30. And I think I actually went around to each group and started sort of talking to them about what that would mean for our circle, how that would help with our pie chart. And some that were sort of more advanced were now working out that they were going to put another row in and create the decimal result from the fraction, and then also the percentage. But that was only 2 or 3 groups where I was sort of having that conversation with them. So after about 5 or 6 minutes, maybe 7 minutes, I pulled them up again, and we discussed that we wanted to get that percentage because that was a part of quite a lot of pie charts. So we put another intermediate row in to find the decimal, and then to find the percentage to 1 decimal point, or to the nearest tenth. Had the discussion that the decimal results should all add up to 1. There was some rounding there, so we get some recurring numbers, so what we had to do with them, so that was good discussion. And then the calculation of the percentages, which no one had really sort of come across much. So we talked about percentage being a ratio, and I just had a little recap on percentages again. I'd talk to them briefly about them. One little thing that they always like, I think, is that I always take the percentage symbol, which they're all familiar with, and explain that that's got the little hint in there that we're dealing with 100, apart from the name, of course, having century in it. So the 1, goes on the angle, and the 2 zeros from the 100 become the 2 circles in the percentage sign. They always seem to like that. And that also looks a little, if we just slant it across a bit, that also looks like a division sign. And if we're doing percentages in the most simple formula, we always need to do division. So we then had a look at the fact that fractions, ratios, which we hadn't included but we talked about, so fractions, ratios, the decimal and the percentage were all equivalent. And what did the percentages need to add up to in this column at the end? Of course, they needed to add up to 100, which was the same as 1, which was the same as 30 on 30, etc. So it was good for reinforcing all of that. I then let them go to do those calculations, and come up with, make sure that their calculations added up to 1 at the end. So that created a fair bit of discussion because there were problems with rounding off. Students who'd rounded off the decimal and then used it in the calculation for the percentage created a fair bit of error. So there's actually a little bit of, for the kids who I thought could take it, there was a bit of discussion about that, where you might represent a number with rounded off, but for your calculation you always wanted to go back to as close as you could the raw data. So once they'd all established that, a couple of them were well into that, and so we made the link about how that would help you find the angles. So 2 or 3 groups were off on their way to creating their pie charts. So 7 or 8 minutes passed, most kids starting to get it. So we talked about how the percentage was going to be represented in the circle. So 100%, if everyone was going to the same school, say Aberfoyle Park, then our pie chart would have just not had any pieces in it. It would have been 360 degrees. So you would have started at 0 and gone through the full 360 degrees. That would represent 100%. What would 50% look like? What would 25%? And so on. And what angle would that represent? I could have left them there to sort of try and work out, well, if 90% is, if 25% represents 90 degrees and 50% represents 180, I think that would have, I could have probably let them sit with that for a while and see if they could sort of work out what's the rule. That would have been quite good. I sort of wanted to keep things moving though, so I just showed them, the raw, like if 100% equals 360 degrees, then whatever their percentage is, how do we find this percentage of 360 degrees? So let's say 23% of 360 degrees. How do we actually calculate that? So I actually just gave them a formula for calculating that. So it ended up just being practicing doing those calculations, there was plenty of learning there because they were getting their divisors mixed up, numerators and denominators getting put in the wrong spot in their calculation. So they ended up coming up with their angles, which of course all had to add up to a 360 degrees. So that was sort of their challenge, to get their angles to add up to 360 degrees. Once they got that, then they could actually just start their drawing and measuring their angles. So there's plenty of, I think there was a nice mix between thinking and then once they sort of had their table worked out, actually just doing their drawing or doing their calculations or whatever. Really enjoyable lesson, great for diagnostic, great diagnostic for me to sort of work out where they were, and a great sort of introduction to percentages. I got some good feedback from the kids about feeling a bit more comfortable about percentages, and then I just did a little bit of sort of, I guess, meta learning, like feedback to them about why I'd chosen that type of lesson, and we talked about what a diagnostic lesson was, and that was a big part of this. So I guess, trying to sort of engage them a little bit that way. So yeah, enjoyable lesson. I've tried to make the discussion about it shorter, so sorry that it's taken 13 and a half minutes. Thanks. Apologise for it taking that long, but I'm just going to add a bit on. One point I didn't mention is when they are calculating the angles, for them to estimate what they expect the answer to be roughly. So if it's if that was in the, say, 40%, what do they expect the angle to be, so that in case they get a ridiculous answer. So just that, reinforcing that step before calculating to estimate. Secondly, in regards to differentiation, all important differentiation. For this lesson, what I actually did was just differentiate pretty much as I was going around the group. So the discussion that I would have with the groups was probably the main part of the differentiation, and obviously they were shooting off on their own anyway, so I think there was enough there for the kids that were struggling a bit in my class. There was enough there for them to all sort of be going at their own level, and then we just sort of shot off as required. I talked a little bit about if a kid was really bright, you could get them starting to work out that relationship between the diameter and how much area would be represented if you had horizontal lines. I think if you had kids that were really struggling, you could have a table already made up for them and maybe some examples of calculating the percentage, so that and you could, I guess, fill out the fractions in the, or the decimals in the columns, and sort of get them to calculate the percentage, or whatever part of it you wanted them to learn. So yeah, just wanted to cover off those couple of points. Thanks.